Hello everyone. So 2 to 3 months ago, I uploaded a video about uh, the connection to the GPRS or cellular network with the ESP32, and in that video, I think I just recorded the screen and just showed like it was awful, and the code was awful, and I don't know why I uploaded that. Anyway. So I went back and I cleaned up the code. Let me just zoom in. So I cleaned up the code so much, like the previous code was a mess. Anyway, uh, so yeah, I decided to remake that video because like so many people have watched it. It's like I think it's about 500 people that watched it, and I know in YouTube like in 2021 500 people are not like it's kind of nothing for some other YouTubers, but hey guys, I don't like searching for videos and finding out that the kinda can't help me, so I decided to remake it, and yeah, here we are. Anyway, so the ESP32, or I'm actually talking about the TTGO T-CALL. I don't. I think it's a development board. Anyway, so it's a development board. It has the SIM800L SIM module that allows you to put a SIM card in it and connect to the cellular network. By the way, guys, that's a 2G module, so only consider using that board if you have 2G connectivity still available in your country. Anyway, so let's talk about the code. Uh, so here I have GPRS.h, this header file that contains everything. I'll talk about it in a second, but just look how clean this code is now. So we have our serial uh, connection just for the serial monitor. Then just with this call, just with this function called GPRS wake up, all the module is set up and you have to look at nothing, you have to care about nothing. You call this function and it sets up the modem as you want. But just like a warning, let me say, this function sets up the module but in a blocking manner. That means once called, you can like your code will do nothing. Like you won't step up into your code, and only after connecting it will continue. That's not actually a problem in most cases, but it this becomes a problem when we're talking about battery powered solutions, let's say, or any IoT solution that's supposed to work on battery and last for a while. That then becomes a problem, and that's why just when we go to the GPRS.cpp or GPRS.h files and see the actual setting up function, you'll see the options that I provided, and actually that's what I wrote here. Anyway, so then I provided another function which is called GPRS connectivity status, and it's a boolean function. It returns a boolean value, and if it returns true, then you're connected. If it returns false, you're disconnected. So you can use this like if you're going to send data or anything, and I'll talk about sending data in a moment. Like you can check if you're still connected or not, and if not, you reconnect, and if you're still connected, you send your data into wherever you want. Anyway, still, this is the non-blocking thing I've talked about. I'll show you with an example in a minute. Then, in your loop function, you do whatever you want. Here, after this call, once you get here, you're connected. That's for sure. Then you do whatever you want. But what to do after connecting to the internet? Why connect to the internet? What things can you do? We'll talk about that in a moment. So let me show you the header file. So this is it, the GPRS.h header file. Here we have our library we're using. It's called TinyGSM. I really recommend looking at the GitHub page for it. It's full of useful data, and we'll look at it in a second. Anyway, before it, you have to specify which module you're using. Here we're using the SIM800 because it supports so many of them, so you have to specify it with a define like this, just like this, so this line shouldn't be removed. Anyway, then we have our definitions of the reset pin, the power key, the mode of power on, the TX and RX for communication. It has also this board has a BMS, a battery management system IC. I forgot what exactly is. I think it's the IP5306 or something like this. I'm not sure. Anyway, you can configure it using I2C. I'm not gonna talk about this in this video, but maybe I'll talk about it in the previous video. Anyway, so in our case, these two we don't necessarily need, and we have our modem baud rate. We have to talk to the SIM800L in serial. That's why we have the TX and RX pins, and we need to talk with it in 115 to 100 baud rate, and that's it. Then we have our states. I've made a state machine for the configuration of the modem. So state machines, oh man, these deserve a whole video on their own. I'll link to some useful videos about state machines so that you understand them even more. Anyway, then we have our GPRS data. The user and the pass, you can keep them empty. Just don't fill anything, like keep them like this. You have your APN. Your APN is your, I forgot what it does stand for. I think it's access point name. I'm not sure. Anyway, each internet provider has their own APN, so Google the APN of your network in your country to find out what it is. And if and only if your SIM is locked, provide the SIM pin. If it's not, like just leave this empty. Yeah, so, and I added a timeout. A timeout is an amount of time, a period of time you keep waiting before timing out, or basically before, how can I say this? Let's say you keep trying. Let's say you keep trying to connect. Once you've been trying for more than, in this case, 10 seconds, you abort. That's the timeout. So I've put a 10 seconds timeout. If you find some troubles with this, like if you find out that your modem is requiring more than 10 seconds to connect, adjust this, make it 20, 12, 20, 15, whatever. Anyway, we have our serial communication here for the modem. We're gonna communicate with it, as I said, using serial. So we've created a serial AT instance of serial. We're using here the ESP32, so we have 3 hardware serials available for us. That's why they're named serial 0, serial 1, and serial 2. And these are our functions, which we're gonna look at in the GPRS.cpp yellow GPRS.cpp file. Anyway, so we include our GPRS.h file. We create our instance from the tiny GSM, and we call it modem. It's our modem. The SIM800L is our modem now. We're gonna use it to connect to the internet, and it takes in the serial reference or serial object, let me say. Anyway, some variables, and here we have our state machine. Here I talked about the non-blocking and blocking manners. So if and only if you're working with a battery-powered system and you want to save time, and you have some other modules that require setting up also. You can put this GPRS.init. You can call this GPRS.init function in an infinite loop and put other modules within it, or it's not within it, but like you in the while loop you put the GPRS in it and other modules so that they can set up concurrently, like just like I wrote here. We have do. Remove this just for clearance. So we do what we do. We GPRS init and we init the other modules we have, and while what? GPRS setup state. This is our variable when it's not equal to the value of GPRS ready, and you put other conditions for the other modules, like not the other module is ready, and so on and so forth. That way you can set up all of the modules in kinda in parallel. But anyway, as I said, it's not that much gain in time, but when you're working on battery powered systems, it makes a difference. Anyway, otherwise you use this one function called GPRS wake up as I provided, and you go on with your life. So first we check if the serial is ready, then we begin our serial communication, and after 100 milliseconds we wait for the serial communication to set up. After 100 milliseconds our GPRS state goes to the init module, and here we are. So we set up our modem. So this function call, where is it? It's down here. This is provided by the tiny GSM module. Like don't worry about it, like just copy and paste it. It's a sequence of actions you need to do, like you pull up you put the modem reset high, then the power modem on high, then the power key high, then you keep it low for 1 second, then you return it high. This way you set up your modem. This is provided in the datasheet of the module. I'll link to it in the description, and it's provided in the TinyGSM GitHub page if you need some more data about it, like consult that page. So yeah, by the way, I provided the link to it. Here it is. Anyway, so after we've set up our modem, we wait for 3 seconds. It's recommended like this. I tested with so many values, like less and more, and found out that 3 seconds is kind of the best value that we could, like the least value we could get for stable and steady and consistent communication or connection. Anyway, so then we restart the modem. It's as I said, it's recommended to restart it for it to start fresh and connect as intended. and just after we restart it, we come here and, well, this in case we wanna, there's your SIM is locked, like we use this to unlock it. Then we connect to the GPR, the APN. As I said, you have to provide this, and these you can leave empty. And after 500 milliseconds, we are ready. And this is this call we detect in our while loop in case we're doing the parallel setting up. And yeah, so other functions that I provided. The put to sleep function, again, for people who are gonna work with battery powered systems, you're gonna need this for minimizing your power consumption. But the problem is we don't have, on the development mode, we don't have full access to all pins of the SIM800L module. And to wake it up from the sleep mode, according to this datasheet in page 160, you can check it out. This is the link. So provided in this datasheet, the datasheet says that you have to send it some data for it to wake up, but there is a pin that should be pulled down that unfortunately we don't have access to. So once put to sleep, we can't wake it up unless we cut power to we cut power, like we reset or something. So I needed this function in a project where I was sleeping for more than 30 seconds and sometimes 1 minute, so it was worth it to put it to sleep because it consumes a lot of power. So how I waked it up, I simply reinitialized it, like I restarted it and did everything in order to make it wake up. It's a hack, but it works. In case you're gonna work with let's say 5 seconds of sleep or even 10 seconds of sleep, it's not gonna be worth it because the modem needs like 10 seconds to wake up, 6 to 10 seconds to wake up, so it's not worth it to put it to sleep. So I recommend you you put it to sleep for more, like 30 or 1 minute, 30 seconds or 1 minute. Anyway, and this is the GPRS connectivity status function. So that's it for this code. But as I said, I'm gonna talk about, like, this is where I provided the last time, and you'll find the link for this code in the description. But I'm gonna talk about what do you do with a GPRS connection. Like, once connected, what can you do? I'm gonna talk about one specific use case, and it is MQTT and sending data to an MQTT broker. Okay. So the same code for the GPRS case I'm using down here. The only difference is that I'm putting all of the functions in one file. All the CPP file is put. The CPP file content is put into the GPRS.h file. I was facing some problems that I didn't know how to solve, so I put it all in one header file and it worked just fine. So this is what we were talking about. It's the exact same file. We import it here, and we'll talk about the MQTT.h the MQTT.h header file. I'm sorry, I had these swapped. It's supposed to be like this. Sorry for that. Anyway, so I'm gonna be using JSON. If you don't know JSON, it's the standard format. It's actually JavaScript. I forgot the full acronym. I'm sure it's JavaScript, but I don't know. Anyway, So it's a standard file format used for communication between so many applications and used in so many fields. So we're gonna use it today. And we have our JSON buffer size. We have a size of the file. The Arduino JSON developers were nice enough to give us a way to calculate the right number, the right size for the JSON buffer in their website. I linked to it here if you're curious. So you decide on your format for your JSON file, study your JSON file. If you don't know it yet, it's so easy, like read the Wikipedia page or anything like that. You'll understand it very quickly. So we have our serial monitor baud rate. I like to use define statements because they don't eat RAM or memory, like they're called uh, uh, derivatives or statements. I'm not sure what they called exactly, but I'm sure they are used for the preprocessor. And the preprocessor is a step in the compilation step. Like code doesn't exactly directly become binary. It goes through so many steps, uh, also called the translation steps. So one of these steps are the preprocessor, and the preprocessor simply looks for these words in the code and replace them with this value even before compiling the code. That's why it doesn't eat RAM or memory. Opposed to this, these are variables that are stored in memory. So this is the creation for our JSON file container. I called it data. Again, you can find all data about all information about the Arduino JSON library in the website. It's very nice. It's very well documented, and they've even made some tutorials online on YouTube. So check them out. Anyway, and yeah, before I forget, I defined the data publishing frequency of 30 seconds. Like each 30 seconds we're publishing, you can change this as you want. Anyway, some variables, and here in the setup function, all we do is we start our serial communication and we wake up our GPRS module. We set it up fully as we've discussed previously. And here in the loop function, it's a small one, as you can see. It's very small. So we check if the function millis, you can see in the Arduino references, it returns how many milliseconds have passed since we started our code. So millis before last time published, we initialize that with 0. So once millis reaches 30,000 or 30 seconds, which is more or equal to the data publishing frequency, we enter this loop. So what we do, this is a variable I created. It's just a string variable called packet, just for demonstration purposes. And then the data variable, I add to it a packet ID. It's a variable here. It's initialized to 0. And then I construct my JSON file as I want. If you know JSON, you know that the notion of tags. If you don't know it, as I said, just read a little bit about it. You'll understand it very quickly just by seeing an example or two. So you simply, like, without predefining or anything, you want to add a tag or a subtag, you just use brackets, first tag, subtag, and you associate the value to it. Here, second tag, its subtag, and the sub of that subtag, and you associate the value. you keep on constructing your document like this. Then I added a call to a communicate function. It's the last function in our code. Our code is very small, very short. So in the communicate function, what do? We first set up our MQTT. We'll come to this in a second when we look at the MQTT.h header file. Then we create a buffer that will contain the serialized data that we created. Also, when you read about JSON, you'll read about serialization. Anyway, so we serialize the data we created into the MQTT buffer we just allocated. Then we connect to the MQTT broker. Then we send the data. And finally, we print, publish it, and the data that we printed. That's it. That's all the code that you're gonna need. You can add here anything you want. You can change the data publishing frequency. You can add sensor data, call for, let's say, you add a function called read sensors. Let's say it's a temperature sensor. So we say temperature. As I said, this is just hypothetical. You like this, and here you do, let's say, data of temperature is equal to temperature, and that's it. You've just created a JSON file containing your data. It's that simple, guys. It's really so easy to work with. So you keep on constructing your file here, and then you call to the communicate function. Just that simple. So let's talk about MQTT. As I said, this GPRS file is exactly the same. Now for the MQTT file, this I added to raise an error if in case you do import. Like, let me show you this error. As you can see here, GPRS must be included before MQTT in your main code. So let's go to our main code. First of all, let's run this. Let's compile this and test that it works. As you can see, it's compiling. Anyway, so it finished compiling without any error. So let's swap these two. So as you can see, I swapped these. Let me save and recompile. And let's wait for it. And here we are. Error: GPRS must be included before your MQTT in your main code. So why did I do that? Well, there's a reason, obviously. Let's return these. And the reason is that I'm using this client, which is the client of this model. Oh yeah, this is the only line I added in comparison to the previous to the start of this video. This client is the one that we're gonna use to communicate and connect to MQTT and everything. So we make a client of this model, and we use it here to create our MQTT client. So the library I'm using here for MQTT is the PubSub client. Again, I linked to it here. It's a very useful library. It's well documented also, so read about it and everything. So our data. What do we need? So in MQTT, you have your broker, which is the central server that organizes all communication between all devices that are using MQTT. So when using MQTT, let's say your phone is supposedly connected to your ESP. If they're using MQTT, they can't be directly connected. They need this middleman. That's called the broker. So what does the broker do? In MQTT, we have things that are called topics, and you can do two actions for a topic or on a topic. You can either subscribe to a topic or you publish to a topic. When you publish to a topic, you have data, you publish it under a certain topic. When you subscribe to a topic, you read data from the topic. Two very simple actions. What does the broker do? It organizes this this flow of data between all subscribed clients, let's say. So there are so many clients. Some of them are publishing data. To some topics, there could be like multiple topics. You can put, let's say you're monitoring temperature and humidity. You put two topics, one for temperature and one for humidity. What does the broker do? Like your ESP have published it to the MQTT topic, which is called temperature. It associates that data with that specific topic. When my phone, let's say, uh, subscribes to the temperature topic, it gives it that data. So on the internet, you can find so many free services for public or private MQTT brokers. I used the io.adafruit.com from Adafruit. It's very intuitive and fun one to work with. This is the MQTT port. Don't worry about it. It's always 1883. Then these are data specific to you. When you make your Adafruit account, you receive these data like the MQTT user, which is you, the passport or sometimes called key, they provide it to you, and the topic. You can have multiple topics. You can have one topic, just as you want. Just when creating the topic, its name should be the username, this one. Then you add feeds. You have to add it like it's an Adafruit thing, an Adafruit.io thing. You write feeds, then wherever topic name. And when you don't have the topic created on the broker, Adafruit automatically creates it for you the first time you publish to it. So don't worry about that. Don't worry if a topic doesn't exist, it will automatically create it for you. Anyway, so we create our MQTT object from the pub/sub client, and as we've been talking about, publish, subscribe, and it's a client, an MQTT client. It's that intuitive, guys. So first you set up your MQTT, you set your server, which is the broker, and the MQTT port. If you have any callbacks, you define them here. Like a callback is a function that triggers when uh, a topic receives new data. Like the moment that a topic receives data, an automatic callback, like this callback function will be automatically called. So if you have like some time sensitive data that you need to check the moment they receive the broker, you need to set a callback. So then our connection here, I made like I'm checking if MQTT is connected or not. If while MQTT is not connected, what do? We try to connect MQTT.connect to the broker with the MQTT user and MQTT password. This rarely doesn't like connect on the first try, like very rarely. But if it happens, like sometimes, like very rarely, I do like 2 attempts or 3 attempts. Like I know because I used to have a print statement here, but now I don't. Anyway, so I wait for 500 milliseconds and then I retry. I used to have a timeout here, but as I said, I rarely uh, fail to connect, so I just left it like this. So that's it. Once connected, like this function returns a Boolean value. Once connected, it returns, like that's it. Then we subscribe, like it's as simple as MQTT.subscribe. This is the callback function. It collects the received message in the received message variable. You can do whatever you want with it. Like in case you have, like you can do whatever you want here. It's up to you. Then the send data function. We have our publish. We publish to a certain topic. As I said, you can have multiple topics. Like you can have topic 1, topic 2, topic 23, whatever you want. You publish the topic, the buffer, and this is the buffer we created here. Like this is the buffer. As you can see, we pass to it the MQTT buffer. This one here. The send data, we pass to it the MQTT buffer, and we publish it to this topic. Then we do the MQTT loop. This should always exist, like you don't have to remove it, so just keep it in here. And this function, the MQTT state, just returns if your MQTT is connected or not, in case you want to check if you're still connected or not before publishing data. So that's useful. That might be useful. Anyway, so these are the two codes I wanted to share with you. So you can check my code in here. Like this is the ESP MQTT. This is the last one we've been talking about. As you can see, this is the Arduino JSON we've been talking about, the serial monitor, all that good stuff. Anyway, and here I provided a simple schematic on how it works. Like if you fail to visualize like how it works in code, this would help you. Like after we reset, we do both. We set up our MQTT. As you remember, it's not that hard, like it's one function call, and we connect to the we set up our SIM800L module. So we check if our GPRS is connected or not. If not connected, we reset the ESP. If so, if already connected, we prepare our data. Then if the data is ready, like this, in case we have data, actual data to prepare, like if you have to wait for sensors or anything, we keep on preparing the data until the data is ready. Once ready, we connect to the MQTT broker, and also you can do like account for maximum connect attempts. Like I used to have like 5 maximum connect attempts. As I said, I removed them, but you can count the connection attempts, and once reached like a maximum connection attempt, you reset your ESP. As you can see, we go here, we reset. Otherwise, and yeah, after attempting to connect, we wait for like 4 seconds, 1 minute. Well, 1 minute is extreme, like 4 seconds, 1 second, 500 milliseconds, wherever. Once connected, we send the data and we wait for our publish frequency. Like we keep on waiting here. Once elapsed that publish frequency, we had 30 seconds in our example. We get back here to prepare the data and we keep on repeating this pattern. So in case you wanna you wanna like design a solution like that works with actual sensor data on with MQTT and GPRS, you can use this for to help you, to inspire you. And in case you're wondering what's this tool, it's called draw.io, like DRAOAW.io. It's a cool open source like software to create diagrams and stuff. So you create here. I've chosen a blank diagram. I'll choose whatever name for it, and it'll keep on loading. And here we are. So we choose our widget. We make it wherever size we want, whatever color we want. Let's create something else, and we link them as we want. And as you can see, it's responsive. It's so cool. Like these guys who developed it are so cool. As you can see, it will follow it all kinds of shapes, and you can put text into them like wherever, like hello. Anyway, you get the point. So guys, thank you for following me for this long. I hope you find my code useful. I'm sorry for the other video, like it was a mess, I know. I was just trying, like, let me try to post wherever to YouTube and see. And it's kind of overwhelming, like finding out that 500 people have seen that video, which I'll be making private from here. Like that garbage shouldn't exist on YouTube. Not even my channel, like shouldn't exist on YouTube overall. Anyway, thank you guys for watching, and if you have like suggestions or questions or whatever, like hit me up in the comments below, and I'll try to answer wherever I can. Again, guys, you can find all kinds of projects on my GitHub page, like, but these are the two that we've discussed today. So thank you guys, and see you in the next video.